So we're going to try this again because third time's a charm. Chapter 1, Plate Tectonics, and this is Section 1, Earth's Interior. Please make sure you have this in your heading. It's really important so you know what chapter you're in and what everything relates to. So we're going to talk about direct and indirect evidence from Earth's interior that scientists use to study Earth's interior. The direct evidence comes from rock samples, and indirect evidence comes from the seismic waves. Big deal. We talked about direct and indirect observations before, so here they are again. Evidence from rock cycles is basically comes from these samples that they take. They drill into the Earth's core about 12 kilometers deep, and they pull out these samples that they're able to study the different components of it. It's kind of like a timeline that shows you all the different minerals and elements that make up that crust layers, and they can draw conclusions as to why those layers are there. Rocks provide quite a bit of information about Earth's interior. The other piece that they get a lot of information from is from seismic waves. Geologists rely on these indirect observations from the seismic waves during an earthquake to understand how things are moving through Earth below us. So the seismic waves can gauge, depending on their speed, they can help us determine what's below us because of how fast they move. The speed and the path they take actually reveal this information of the structure of the planet. So from this data, the scientists have actually learned about Earth's interior and that they feel that Earth is made up of these several layers, and we're going to talk about these layers. So let's take our journey to the center of Earth. Three main layers is the crust, the mantle, and the core, but we're going to break those down into some more specific layers. So you need to understand that the crust, the mantle, and the core actually have multiple layers here. These layers vary greatly in size, composition, temperature, and pressure. So they're all different, and they all are unique for their own special things. The temperature. This is the surface and surrounding rock is cooler. So the temperature here on Earth that we know Earth has to be, our temperature is determined by the sun and those other elements. But the rock below us is affected by Earth's inner core, and it's much cooler because we have this atmosphere cooling it off. So 20 meters below, the rock is actually going to get hotter, and for every 40 meters you descend from that point, it increases by 1 degree Celsius, and it's going to get really, really hot, and extremely hot that you would burn up. So between the temperature of Earth's core and the pressure, you would never make it to the center because it would be one of the two would kill you, probably the pressure before the heat. Scientists believe that the heat is a result from the Big Bang Theory, from when the planet was created. So you have to understand that theory to understand where they're coming from to get that information. So the high temperatures, they believe, are a result of this leftover formation of the planet. So the pressure increases as you descend because you have the weight of the rock and atmosphere above acting down on you. So just like we talked about the ocean water, when you descend down, you can only go so far because of all the pressure. Same concept, same thing happening. You're just now having air pressure versus water on top of you. So as you move through the crust, this is the outer layer of the skin. The crust is a layer of solid rock that includes both dry land and the ocean floor. Yes, it's in green for a reason. You need to know it. On the crust, you find rocks and mountains, soil, water. So basically things you see here on Earth, that is the crust. The crust is thickest under mountains and the thinnest at the oceans because you're getting closer to the floor of the crust. It's between 5 and 40 kilometers thick, up to 70 kilometers thick at the mountains because obviously you're moving so much higher. Oceanic crust is made up of rocks such as basalt, and continental crust is made up of granite. These two things, oceanic crust, continental crust, you need to know. We will talk about this later in the book. Basalt and granite, how they're made, where they come from, why they're important, you need to know that. The mantle, okay, here's a diagram over here that we're going to talk about a little bit more and dissect this. It's 40 kilometers beneath the surface you enter the mantle. So below the surface is down 40 kilometers from there, you're entering the mantle. Earth's mantle is made up of rock that is very, very hot, but it is solid. The mantle is nearly 3,000 kilometers thick. This is our thickest one. The uppermost part of the mantle is very similar to the crust. The uppermost part of the mantle and the crust together form a rigid layer called a lithosphere, and it's about 100 kilometers thick. So right here below the crust, so here's my crust, below that, okay, This tan layer, this is my lithosphere. All right? No. Yes. Yes. These brown layers here is going to be my lithosphere. Now, the asthenosphere is this orange layer right in here, okay, that is going to heat up my lithosphere. So the asthenosphere, this portion of the mantle is beneath the lithosphere, is less rigid than the rock above it, and it's softer. It can bend like plastic. It's almost hotter than the lithosphere. So it's what kind of caused it's starting to bend and move a little bit, but it's not like lava, okay? It's just a softer rock that can bend and mold like clay. The lower mantle is solid, and it's very hot, and the solid material extends all the way to Earth's core. And Earth's core is what's going to actually really cause a lot of this heat and where the mantle is getting heated up at. The core is made mostly of metals, iron and nickel. It consists of two parts, a liquid outer core and a solid inner core. The inner and outer core is 3,486 kilometers thick, so it's pretty thick. The outer core is a layer of molten metal that surrounds the inner core. So kind of like this tangerine here. I've got this outer layer, and if I peel it back because it's soft and it molds and bends, I have a solid ball on the inside. Okay? So despite the enormous pressure, the outer core is liquid, and that inner core, because of the pressure of everything else acting on it, creates a solid, dense ball of metal made up of iron and nickel. And it's so much pressure that it can't spread out. So this layer here, this liquid layer, the outer core, actually doesn't allow it to spread out. It keeps it contained and in there, creating that thick ball. So it's kind of like an orange in some aspects. Now, scientists have also found evidence that the core may contain things like oxygen, silicon, and sulfur, so they're still investigating this piece. Scientists also think that the movements in the liquid and outer core create our magnetic field. We have a North Pole and South Pole, okay? This North Pole and South Pole actually attracts metal. And this is how our compasses work because we have a North Pole and South Pole. So the metal points north, okay? And so in our compass, the little arrow is going to find the north, and then you can always find north because the little metal arrow is going to point north, and you adjust your compass, and so you can always find your direction if you're moving north, south, east, or west. It's because of this magnetic field. This magnetic field we're going to come back to and talk about. It's very, very important, and it really affects some of the things that happen here on Earth. All right? So if you have any questions about the layers of Earth, inside of Earth, and how it's made up, please come see me, and I'll talk to you later.